So now we're going to graph a cosecant function. So remember that cosecant of t is equal to 1 over sine t. Okay, so I'm going to get a little quadrant here going. And remember those ordered pairs, 0, 1, 1, 0. I'm sorry. Well, remember them, but I just wrote it wrong. 1, 0, 0, 1, and negative 1, 0, and 0, negative 1. Okay, so let's think about our quadrantal angles. First of all, we need to write this as cosecant of x and what x is. So 0, then we know we're going to do something with pi over 6, pi over 4, pi over 3, and then we'll have the next quadrantal angle, pi over 2, and then I'm going to go ahead and fast forward here. So pi, 3 pi over 2, and 2 pi. So we'll see if that's enough to get us a nice graph. All right, let's mark off 2 pi. And let's start talking about this. Okay, so when we're right here at 0, remember sine is going to be on the unit circle. Sine t is equal to y. So you're going to have 0 for y, but it's the reciprocal, so that's going to be undefined. That means an asymptote. Okay, pi over, well, let's go to the next quadrantal angle. So 0 over 1, so 1 for sine of pi over 2, reciprocal it, that's going to make it 1. Okay, then at pi, well, you've got 0 again, don't you? So that's going to be undefined, because 1 over 0, right, when you reciprocal. So that's going to be another asymptote. And then 3 pi over 2, well, you're down here at negative 1, so it's going to be negative 1. And then 2 pi, you're going to be back full circle, so that's going to be undefined and an asymptote. Okay, now let's mark them off here. So I've got 2 pi, there's pi over 2. I'm sorry, pi, then pi over 2. Here's pi. And 3 pi over 2. Okay, now what about our special angles? So the sine of pi over 6, that's 1/2. So reciprocal, it's going to be 2. Pi over 4, if you it's square root of 2 over 2, but then for sine, but then you've got to do the reciprocal, so that's the square root of 2, which is 1.4. So we might remember that from before. Then pi over 3, that's going to be 2 times the square root of 3 over 3. You can think back to your cofunctions, right? Secant and cosecant, they're cofunctions. So, you can use those properties. And if I'm remembering right, that was 1.2. Okay, so now let's get some points on this graph and see what's going on. It looks like we're starting out at 0. We have an asymptote right there. Okay, and then we have an asymptote at pi. And we have an asymptote at 2 pi. Now remember, for cosecant, one period is going to be 2 pi. So we've done that. All right. Now what happens at pi over 2? At pi over 2, whoops, I didn't put in a 1. Here's a 1 and a negative 1. Okay. So at pi over 2, we're up there at 1. And then at 3 pi over 2, we're down here at negative 1. Now they have a visual in the textbook. Sometimes I think it's confusing, but it might be helpful after you looked at this to look at the video, because what you're doing is you're doing the reciprocal of that cosine curve, or the sine curve. Okay, so if you want to think about that later. Now what's going to happen here in between? You have those little special angles in there. Okay, so at pi over 6, it was up there at 2. And so it was going like way up here. And then at pi over 4, it was like 1.4. And then at pi over 3, it was coming down to like 1.2. So you get this shape kind of like that. And then it's going to continue back up. We're expecting it to look very similar to the secant curve, right? The problem is the asymptotes have moved. That's the difference. And then you're going to have a curve down here that's going to go, whoop, something like that. That would be one period then for the cosecant curve. But notice the difference in the asymptotes compared to the secant curve, okay? All right, so let's put this together then. If you have y equals a cosecant bx minus c, well, plus d, we'll put it all in. Okay, so this is going to tell you your phase shift, and c over b, it will be the phase shift. And d will tell you your vertical shift. And those are important. We usually look at those later. You know, first we look at the period and we look at the stretch. Okay, so A, the absolute value of A, that's going to be your stretch factor. And then the period, you're going to find that by going 2 pi over the absolute value of B. Okay. Now, if we want to talk about, oh, we've got all that. I should have wrote it down here. Okay. The domain. Well, it's all real numbers except where the asymptotes are. Now this time though, the asymptotes are at every unit of pi. Pi, 2 pi, 3 pi, 4 pi, 5 pi, and in the other way, negative pi, negative 2 pi, and so on. So it's going to be all real numbers except when x cannot equal, I guess I should put, x cannot equal pi k. Oh, I got to take into consideration if the period changes. Okay, and k this time though, k is just an integer. So that's the difference, is where those asymptotes are for the cosecant compared to the secant curve, okay? So if you remember for the secant, the asymptotes, they were at pi over 2b k, where k is an odd integer. So you might say, well, why is that? Because I need the asymptotes to always be a unit of pi over 2, okay? And it's not at every unit of pi over 2, it's every other one. So that's why k has to be an odd integer. So you have to kind of look at the secant curve and you'll see that. It's a little bit easier with the cosecant curve because they're just, all the asymptotes are at an integer of pi, okay? The range is going to go from negative infinity to negative 1. I hope I put a square bracket on that other video. Union, square bracket 1 to infinity. I'll have to go back and look. The asymptotes, that comes from here. So it's when x equals pi over 2bk, where k is an integer. And symmetry, cosecant is an odd function. So it's symmetric about the origin. Okay.